If you read the news today, it can feel like the tech world has split apart into a storm of buzzwords. You hear about artificial intelligence, machine learning, deep learning, and generative AI. But are these actually different things, or are we just using four different names for the exact same concept? Throwing these terms around interchangeably makes trying to understand modern digital tools incredibly confusing. It's easy to feel lost when the vocabulary keeps shifting. To make sense of it all, it helps to build a mental map. Instead of viewing these as competing ideas, think of them as a set of nested rings, like a Russian nesting doll. Each concept lives completely inside the one before it. Fitting these four layers together shows us exactly how computer science progressed from the very beginning to the present day. Let's start with the oldest and broadest concept, the outermost circle, artificial intelligence. Beginning all the way back in the 1950s, AI was simply defined as the science of making computers act intelligently. To achieve this, early computer scientists relied on rigid instructions. They wrote thousands of lines of strict if-then logic rules, trying to program every possible decision a computer might need to make. These strict, hard-coded rules were highly successful for contained, rigid tasks. If you want a computer to play a structured game of chess, a massive list of if-then rules works perfectly. But that rigid logic hit a wall when faced with the messy, unpredictable real world. Think about trying to write a mathematical rule for what makes a cat look like a cat, a pointy ear or a tail. The variations are endless, and you simply cannot write enough if-then statements to cover them all. So artificial intelligence is really just that big original dream. It is the broad goal of making a machine act smart, regardless of the specific method we use to get there. That brings us to our second ring, a smaller circle inside AI called machine learning. This represents a shift in strategy. Instead of programming exact rules for every situation, scientists decided to let the computer find the patterns on its own. This diagram shows how this works. We feed the computer massive collections of examples, like these labeled emails. You experience this daily with your spam filter. By analyzing messages already labeled as spam or safe, the machine gradually discovers the hidden patterns itself. Because the machine is finding the patterns itself, its performance improves automatically as it gains more and more experience. A human programmer doesn't have to go in and write a new line of code for every new type of spam that appears. Machine learning changed computer science by letting machines learn directly from the data we give them. As problems grew even more complex, we needed to go a layer deeper. This third ring is deep learning. It sits inside machine learning, and it tackles problems entirely too complicated for basic pattern recognition. This method takes inspiration from how the human brain works. Scientists build webs of interconnected digital layers, stacking them so the system can process information in stages. Imagine asking a computer to process a photograph. The very first layer of the network doesn't look at the whole picture. It might only look for basic, simple shapes or sharp edges. Then it passes that information along. The subsequent layers combine those basic edges into complex shapes, passing data deeper and deeper into the network, until the final layer successfully recognizes a complete human face. While this layered approach requires massive amounts of computing power and data, it is incredibly highly effective. It is the engine that powers modern speech recognition on your phone and the navigation systems in self-driving cars. Deep learning is the brain-inspired, layered engine we needed to handle the messy, unorganized information that makes up our real world. This brings us to the center ring, generative AI. This technology takes those layered digital brains we just talked about and uses them to create rather than just organize data. One popular method pits two neural networks against each other in a sort of digital game. One network tries to generate a convincing fake piece of data, while the second network acts like a detective, trying to catch the forgery. They repeat this competition millions of times. Eventually, the generator gets so good at its job that the system learns to generate completely original, authentic-looking content, like a photograph of a person who doesn't actually exist, or a brand new poem. Generative AI allows computers to invent brand new things instead of only analyzing existing data. So let's look at the full map. We have artificial intelligence, machine learning, deep learning, and generative AI. These aren't four competing technologies fighting for dominance. They are a nested evolution of intelligence, acting as a unified system. When you sit down to use an advanced chatbot or a modern digital tool today, you are actually relying on all four of these nested layers simultaneously. The digital world makes sense when you look at it through this lens. We started with the broad dream of smart machines, zoomed into systems that learn from experience, dug deeper into digital brains that handle complexity, and finally arrived at the core, machines capable of true creation.